Hello and welcome to DataCast Solutions, Statistics and Data Mining 101 using KNIME. In this chapter, we're going to be covering the terminology relating to variables so that you understand what those fields mean before we begin using them. In statistics and data mining, a variable has two defining characteristics. It is an attribute that describes a person, a place, or thing, and it has a value that can vary from one entity to another. The best example is a person's hair color. That would be a potential variable in an algorithm or a model, which can have values like blonde for one person and brunette for another. So in the example here, a person can have a gender of male or female. Height would be a variable, and you could be 5 feet tall or 6 feet tall. And hair color might be blonde and brunette. And your age might be 6 years or 60 years. Some variables are described with words or strings, character data, such as gender and hair color. But to be useful in statistics, the ones most valuable are the variables that are described as numbers, such as age and height. A qualitative variable, also called a categorical variable, are things that describe the quality of something. For example, the color of a ball, the breed of a dog, character strings, if you will, that describe something. Quantitative variables take numeric values, or quantities, and are used to represent a quantity of something. So in terms of representation, for descriptive statistics, variables are qualitative, which are words or strings, and quantitative, which are numbers. However, numbers need to be broken down further, that a qualitative variable can be classified as either discrete or continuous. A discrete quantitative variable takes on a finite number of values, where continuous can be any value between a maximum and a minimum. In other words, any possible value is available for that variable. Another way of looking at that for quantitative variables, for continuous, would be any value, generally something with a right to the left, or numbers to the right of the decimal, where a discrete value would be anything that would support generally just integers, a predefined set of values. So let me give you two perfect examples of a continuous versus a discrete variable. Let's say a firefighter must weigh between 150 and 250 pounds. Well, their weight as a fraction of that could be any number, an infinite number, in between those two variables. That would be a continuous variable. I could be 151 pounds, 150.1, 150.2, and so on. If I flip a coin, however, the number of heads could be any integer value between 0 and infinity. However, it would not be possible to get 2.3 heads, for example. It must be an integer. So a discrete variable by its definition must be an integer. Now this can get a little confusing. So a continuous variable can be further categorized into either an interval or a ratio. Interval variables, for which there are certain characteristics, is that they can be measured along a continuum of a maximum to a minimum. Ratio variables are also interval variables, but with the added condition that 0 as a measurement indicates that there is none. I know that's a bit confusing, so let's take a look at what that actually means. As an example, we measure temperature in the Fahrenheit scale. So the difference between 20 degrees Fahrenheit and 30 degrees Fahrenheit is the same as the difference between 30 and 40. This is an interval variable. It is not a ratio, because a value of 0 does not indicate the lack of a temperature. It just means that is the temperature. Qualitative variables are also known as categorical variables, we said, and they can be further categorized as nominal, dichotomous, or ordinal. Now, nominal variables are those that have two or more categories, but which don't have any intrinsic order. For example, a real estate agency could classify their types of property into distinct categories, such as houses, condos, or bungalows. That would be a nominal value. A dichotomous variable would be one that has two specific values. For example, male, female, on, off, true, false, basically two values. Where ordinal variables are very similar to nominal variables with one exception, there is an order to them. For example, military rank. You are a second lieutenant, then a first lieutenant, then a captain, major, lieutenant colonel, colonel, general, etc. There is an order to the ranks, and it's not alphabetical. So qualitative variables are broken down into nominal, dichotomous, or ordinal, and you can see they have multiple values, two values, or multiple values that have been ranked. And finally, independent versus dependent. The independent variable is usually called the experimental variable, manipulated, or predictor variable. It's a variable that is being changed in order to observe the effect on the dependent variable, sometimes called the response or the target. For example, if I wanted to measure a person's strength as they get older, okay, the age would be the independent variable, and the dependent variable would be their strength that I'm measuring. So finally, this acts as a reference summary, the type of variables that you see: qualitative variables and quantitative variables, and a breakdown of each. So a quantitative being the categorical in the forms of nominal, dichotomous, or ordinal, and quantitative variables, which are discrete or continuous, and further broken down into interval and ratio, and then the dependent and independent variables. That completes this chapter of the class. Feel free to move on to the next chapter.